in the beginning. That's okay. We got it all in there.
It starts
I'm gonna
Wednesday and it
Where's
closes
these?
next Wednesday.
Oh, okay, Wednesday.
Yeah. Marjorie, you gonna sit there and move to the next one? It doesn't matter. It doesn't matter. I was just gonna move this according to where you were. Okay. All right, I'm gonna go ahead and start. Are you allergic to math?
Highly.
The heck? All right, here is the problem that we're gonna work on. You have 2 cars, and we're deciding which car we're gonna buy. You put 10 gallons of gas in the car and drive it until it runs out of gas. We do this 15 times. I want to know the mean, the standard deviation, the shape, the median, and the range for each car. Then we need to decide which car we're going to buy. What kind of standard deviation is this? Sample or population? What do those numbers represent for car 1? All the times I drove it, or part of the times of all the times I drove it? Did I drive it 100 times and I'm only telling you 15?
Oh, no.
So I drove the car 15 times and I'm telling you every piece of data I have. So it'd be what kind? It would be population. Because I'm telling you all the data I have. That is all the times that I rode it. I rode around that car. That's every single time. L1, L2. Make sure you call them the right name. The shape means, tell me, is it symmetrical, bell-shaped, or is it right skewed, or is it left skewed? Huh?
What was that you said?
Oh, the shape. I said find the mean, the standard deviation, the shape, the median, and the range. The shape is, tell me if it's right skewed, left skewed, or bell-shaped. Tell me what the shape of the graph looks like. Mean, standard deviation, shape, median, and range.
For both sets of data?
Yes, for car 1 and car 2. Yeah. Myers and Josh, you're not in trouble, but if y'all will both see me after class for like 2 seconds. Not in trouble. And for those of you who didn't hear it at the beginning of class, our test opens up this Wednesday for chapters 1 through 4 and closes next Wednesday. And your homework for chapters 1 through 4 is due this Sunday at midnight, 11:59. calculation, the shape of the graph, the median, and the range. And if you're not sure of the shape of the graph, you have a backup method. First thing I did was stat edit. I went to the top and hit clear enter. Does not matter if you type the data across or up and down or skip a number, as long as you have the data in there. So this is my L1 and this is my L2. Now, I'm going to need to get those sets of data out. So I'm going to do stat, calculate, 1var stats. Now, I already have L2 in there, so I'm just going to go ahead and do the stat calc of L2. There's page 1, and then I'm going to scroll down, and there's page 2. Maybe not. Here's page 2. So that's going to be my car number 2. Let's see if I can find a spot to put it in just a second. There's my data for L2. And when I do L2, I just need to make sure that when I do stat calc, 1var stats, that it has an L2 there. This time I want to do L1, so I'm going to hit second 1 to get my L1 there. So this time it is only looking at the L1 data. So there's page 1 of car 1, and now I'm going to do page 2 of car 2, because this may be one of those questions that we were talking about that has 15 parts. So I'm going to make sure that I have everything there. So the first thing it wants to know is, what is the mean? The mean is going to be my, what? X bar, but what are we going to call it? Mu. So we look at it as the X bar, but we call it the mu, which is going to be here and here. What am I going to look for my population standard deviation? Sigma X. So that is going to be here, and that is going to be here. Did I type it in right? Are my numbers looking like yours?
I have a question before. How'd you get that?
Stat, I went to, I did stat edit and typed in my data, and then I hit stat, over to calc, and then I hit enter to 1var stats, and then I hit enter, 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 and there's page 1, and then if you hit the down arrow, that gives you page 2.
Okay.
Yep. All right, so, shape. Let's go to median first. What is my median? My median's going to be here for the first one, and my median's going to be here for the second one. And my range is going to be high minus low for each one. Max minus min. Yay? Now, for the shape, where would I need to go? What would I need to do to look at the shape? Okay, what I would do is probably go to second Y. And once I'm in second Y, I would go in and say, what do I have it turned on to? I have the histogram turned on to. So I'm going to do zoom 9 and just see what it looks like. not, second Y, stat plot on.
Great.
Okay, L1 does. There we go. So, from that, it looks like it's going to be what kind of shape?
Bell.
Bell shape or symmetric, okay? Now, when I go do the second one, I'm gonna do second Y. I'm gonna go in, but what do I have to change now? I've gotta change that to L2, because I want it to look at list 2. I'll pull that over to make sure that you see it. I wanna change that to L2. So now, when I do zoom 9, or when I hit enter first, enter, and now I hit zoom 9. Already doing it. Zoom 9. Okay, what does that one look like? Okay, I hear right skew. Now, if we are weary of whether it is truly right skewed and truly symmetric, what do we compare?
The mean and
In the mode?
no, the mean and the median.
Yeah.
The mean and the median, okay? So for this one, our mean is 223.6, our median is 223. Those are pretty much the same. So because our mean and our median are equal, that is symmetric. Over here, our mean is 237, our median is 230. Our mean is that way. So what kind of skewness is it?
Right.
Right skewed. So for this one, the mean equals the median, which also tells me is symmetric. For the other one, our mean is bigger than our median, which also confirms that it's right skewed. That is just another way to back up your picture. Now, I know I got a bunch of crap up here right now, so I wanted to kind of show you everything in one. So if you come down, this tells you exactly what to do. Enter data, car 1 into L1, do one of our stats. L1, do your mean and standard deviation. L2, do your mean and standard deviation. To get your graph, if you're going to look at your mean, you're going to look at your spreads, you're going to look at several things. I'm going to go back to my graph in just a minute. So, down here I read it a little bit prettier. Our mean, which we got from our X bar, but we're calling it mu because it's a population. Our standard deviation is population, so we call it sigma. This one was bell-shaped, this one was skewed right. Our median we got from the MED, and our range was high minus low. Now, let's talk about it for a minute. The averages, this one had a little higher average. So we're talking about cars. How far can a car go on 10 miles a gallon? So this one can go a little bit further, which makes that car look good, right? Standard deviation. This one has a higher standard deviation, so what does that mean about the cars?
Less consistent.
Less consistent. They're more spread out. So you may get in that same car and it may go 200 miles on that 10 gallons, and the next time you may get in it and it may go 400 miles on that 10 gallons. So there's no consistency, where this one has a half the spread, which means every time you get in it, it's pretty much going to be the same gas mileage every time you get in it. It's more consistent. This one's bell-shaped, which means it has outliers at both ends. This one is skewed right, which means all the data is at one end and it has outliers at the other end. The medians are about the same. Oh, look at the range. 166 miles per gallon separates this one and this one. 93 separate this one and this one. Which car should we buy? Car 1 or car 2, and why? If you were buying it just on gas mileage, which car should you buy?
2. Just on gas mileage, 2. But
I'd go with one.
Wow.
Considering all
It's
the,
more, I would go with two if it was just based off of gas mileage, but
considering all the data, one.
Considering all the
because it's
data, I'd go
consistent.
with one.
If it's just gas mileage, it would be 2, because this gets more gas mileage on the average. But if you're looking at all data, what are we gonna go with? 1, because it's more consistent, because you don't wanna put 10 miles a gallon, 10 gallons in your car and don't know how far you're gonna go. It's all over the place, because it's spread wide open, that standard deviation's all over the place.
So what does the range tell us in this?
The range tells you that, what separates the least amount of gas mileage from the highest gas mileage. So for this car, it may have gone 200 miles on 10 gallons of gas, or it may have gone 293 miles on 10 gallons of gas.
Oh, okay.
Here, it may have gone 200 gallons on 10 miles of gas, or it may have gone 366 miles on 10 gallons of gas.
Gotcha.
So that is also kind of telling you the same thing that this is telling you, sort of.
Yep.
It's telling you that these are more spread out, the data is more spread out.
Yeah, that makes sense.
So not only do you have to do the problems, you have to understand what it's telling you. So this is saying car 1 has more consistent. We expect it to be symmetric. The mean and median are approximately equal. Car 2 is skewed to the right because the mean is larger than the median. They both have similar measures of center. Remember, the center are the mean, the median, and the mode. Car 2 has more dispersion. The dispersion is the spread, which means it has a larger range, larger variance, larger standard deviation. So car 1 is probably the better to buy, mainly because of exactly what y'all said. It's more consistent. It's more reliable. All right. One more on this one. Suppose Professor A, Alpha, or Professor Omega each teach biology. You need to decide which professor to take for the class, and you have just completed your intro stats course. Records obtained from the past students indicate that students in Professor Alpha's class have an average of 80 with the standard deviation of 5%. Professor Omega's class have an average of 80 with the standard deviation of 10%. Which professor do you want to take? So if I write it out, both professors' classes had an average of 80. But Professor Alpha had a standard deviation of 5. Professor Omega had a standard deviation of 10. Who are we going to go with? Alpha or Omega?
Alpha because he's more consistent.
Alpha because the grades are going to be not as wide. So that's telling you that these grades are going to be closer together. So you're more likely to make around an 80. Here, the grades are going to be spread out. So you're going to be, you could be making a 20 or you could be making 100. They're all over the place because they have that higher standard deviation. So I'm going to be taking Professor Alpha because of the lower standard deviation. The grades are more consistent. They're going to be closer to that average. Almost everybody in the class is making an A. AD, not an A. Then we'd all take him. All right, that was a long section. Okay, let me save. This next section is not that bad. Let me pull up. The next section is 3.3. We're still dealing with L1 and L2. But here we did the mean, median, and mode of just L1, or the standard deviation of just L1, or we just looked at L2. Now we're going to be combining them together. We're going to see how L1 and L2 relate together. So let me get rid of him. Okay, so measures of central tendency, which is like your mean, median, and mode, and measures of dispersion, which is your standard deviation, your variance, we're going to be, and range, we're going to be doing those for group data. Group data is when we did a problem like 0 to 9 miles to school, 10 to 19 miles to school, 20 to 29 miles to school, 30 to 39 miles to school. And frequency says 4 people drove between 0 and 9 miles, 3 people drove between 10 and 19 miles, 7 people drove between 20 and 29 miles, 1 person drove between 30 and 39 miles. What would my mode be?
20 to 29.
Oh, yes, 20 to 29 would be my mode. Good. So, group data means you have a group of data to put in. Okay? Now, it can be tricky, but we're going to get through this. We're going to do the mean and standard deviation of group data. Now, the problem with this is not everything is equally weighted. You have 4 people in this group, you have 3 people in this group, you have 7 people in this group. They all are weighted differently. Just like in this class, your homework counts a little bit, your tests count a lot. Everything's not weighted the same. So what we do is we put them in L1 and L2, and we use them together. Okay? So we're not just doing car 1 and doing car 2 separately. We're doing the data together, and we're weighting them together. Now, here's the problem. I can't put 30 to 39 in my calculator. I can't put 10 to 19 in my calculator, so I have to put a number that represents 30 to 39. How do you figure out what would be a good number that would represent 30 to 39? How would we know? Or what would be a good number that would represent 0 to 9? Would I use the front number, the back number, a middle number?
The last number? No.
Number in the middle.
The number in the middle. So you can't put the whole thing. So what we need to do is we need to find those numbers in the middle. That's called the midpoint. And that midpoint is going to represent that whole group. You just pick somebody in the middle and say, hey, you're representing this group. So between 0 and 9, I need to know a midpoint. So here's what you do. You add up the 2 front numbers and divide them by 2. Come over here. So I'm going to do front number plus front number cut in half. That gives me the midpoint of that one. So to get the midpoint of the next one, I'm going to do front number plus front number cut in half. So what's 10 plus 20
30.
cut in half?
15.
That's going to be the midpoint of that one. So you do the 2 fronts, cut them in half, and back that thing up. It always goes to the previous one. Add them up, cut it in half, and back that thing up to the previous group. I'm going to do some. Alright, so we come down here for a second. This is telling you what I just said. To find the midpoint, you take your 2 lower class limits, add them up, and divide by 2. That's going to give you that midpoint. Your midpoints are what you're going to put in for L1. Your frequency is going to be what you put in L2. And then when we do 1-bar stats, we're not going to just do L1, and we're not going to just do L2. We're going to do L1, comma L2. Saying, take my data from L1 and combine it with the weights of L2. Now, if you don't know where your comma is on your calculator, your comma on your calculator is right above the 7. So for this set of data, you have to say, I'm taking these categories and I'm combining it with these weights. What the frequency is, what the weights are. Alright, so let's look at an example. Let me delete this page. Okay, so they gave me this stuff and they want to know the mean and the standard deviation. So So 344 people make between 0 and 19,999. 98 make this, 52 make this. So I have to include the data and I have to include the frequency. But I can't type that data in, so I have to get the midpoint. So I'm going to come in and I'm going to make a cute little column right here in the middle. And I'm going to call it the midpoint. And the way that I get the midpoint is I add up the front two numbers and cut it in half. So 20,000 plus 0 cut in half. 10,000. Then to get my next midpoint, I'm going to add these front two numbers, 40,000 plus 20,000 cut in half, and back that thing up. Because that midpoint should be between those two numbers. So to get this midpoint, what am I going to do to get that midpoint?
Add up 80,000 and 100,000 and divide it by 2.
So I just randomly picked. So if I want to get this midpoint, it's going to be 100,000 plus 80,000 divided by 2, which is going to give me 90,000. And then this one would be, what is that one?
50.
40? Halfway between 40 and, that's 50, isn't it?
50.
50, 70, 90, 110, 130. This one just happens to be pretty numbers. I always start off with an easy one. Okay? We good? Now, we're going to type this into our calculator. L1 is always your category or your group. L2 is always going to be your weight or your frequency. So go ahead and type your data in. Your L1 is always your midpoint, which is your category or your group data. L2 is always going to be your weight or your frequency. Now, you've got to be careful now. If you type these in, this has to be beside this. So if you type it out of order, you just got to make sure these two are beside each other because these two go together now. Up until now, it didn't matter. 52 goes with 50,000. 13 goes with 90,000. Go with me?
So the midpoint is L1 and frequency is L2?
L2. So this is going to be your L1. This is going to be your L2. I think I wrote it prettier down here. So this is going to be your L1. This is going to be your L2. Your frequency, but you have to make sure that if you type something out of order, whatever has to be next to it, because these two now are dating. They're going together. Now, once you do stat edit and you get your data in there, you are now going to do 1 var stats of L1 and L2, or L1 comma L2, because you're using the L1 data and the weight of the L2 data. And they want to know the mean, and they want to know the standard deviation of the sample. They want to know the mean and the standard deviation of the sample. But you've got to do L1, L2, or you have to do L1 comma L2 because we're using those sets of data. Now, can you shut that door for me, please? Do what?
Yeah, it's not like they put a comma either.
Is it side by side or is it on top of each other?
I think
Side by side.
Yeah, side by side. Like if you press it and then.
Okay, if you have the list, the frequency, you're gonna have